you save yourself from having to deal with the negative 1/2 x and negative 1/2 times 4. So negative 1/2's reciprocal is negative 2. If I multiply by both pieces, on the left it disappears, giving me x plus 4. And on the right, I now have a negative 32. Again, eliminating the need to deal with negative 1/2 times x. This is a huge, huge hint. Very, very helpful. After you subtract your 4, you're going to end up with negative, why did I write it like that? Negative 36. Negative 36. I'm going to do another one with you just for fun. It's number 31, and what it says is 21 is equal to negative 3/2 x minus 2. Just like we thought of this like the 6 and we divide it out, we're going to do the same thing here, multiplying by its reciprocal. Negative, same sign, 2/3. Remember, something's reciprocal is what would be multiplied by it to equal a 1. So negative 2/3 times negative 3/2 cancels itself out, leaving me with x minus 2 left here. Over here, the 3 and the 21 reduce each other, so now you have a 7 here, and it becomes a negative 14, because it's a negative 2/3 is the reciprocal of negative 3/2 is. Something's reciprocal is always the same sign as whatever the original thing was. That's number 31. Adding 2, you should end up with a negative 12 as your value for x. That's 31. I'm sorry, that was 33. I wrote 31 twice. 35. All these things do, guys, is get bigger. They don't necessarily get harder. And if you're not prepared for some of the extra steps, you might end up making a mistake somewhere. Here's number 35. Okay, so what we have right now, we have some business going on right here, and we have the plus 19 sitting there. Some of you might be thinking, well, let me distribute this. Yeah, that's true. But an easier way to do it is going to be to get rid of your 19, which gives you a negative 21, which is now equal to 3a minus 5. 3a minus 5. If I distribute it in, I'm going to have 3a minus 15 is all of that. But instead of distributing, just like I did up here, I'm going to divide by the thing that precedes the parentheses. Divide by 3. And you end up with a minus 5 equals negative 7. Adding 5, you're going to end up with a negative 2. Doing it this way is almost like reducing a fraction. You're, instead of multiplying it in through the distributive process, you are dividing it out so that you never have to deal with that 3 as the coefficient of a, 3 as part of the negative 5. That's number 35. 37 is the exact same thing, only it's written a little bit backwards. That's why I'm doing multiple examples of this, because it's not really something that has examples in the book, and I wanted you to see it so that you would be able to do it. Here's 37. Negative 3 is equal to 4 multiplied by k plus 7, whatever that is, minus 15. So like the one above, we're going to deal with this piece first by adding it. That gives you 12 being equal to 4 times k plus 7. Isn't that convenient? 12 is divisible by 4. So we're going to divide out that 4. 3 is equal to k plus 7. So k must equal negative 4 after I subtract the 7. This is extremely useful, this dividing by the thing that you were going to distribute, if this item is a multiple of 4. If that was a 5 here, it wouldn't really be quite as handy. You'd still end up with a messy decimal type answer. But because I know this 12 is divisible by 4, rather than doing 4k plus 28 equals 12, it's easier to just reduce it out right now. This one isn't quite as easy, or doesn't have any really helpful steps that I can share with you right off the bat. Because I've got this C here, and this number 3 does not divide evenly into this or that, what I just showed you isn't all that helpful, so you have to go through the long steps, which is distributing. Combine your C's, add 6 to both sides. 7C is equal to negative 28, lucky for us. And that makes your C equal negative 4. Hold me with me back there, bud. I know, it's a lot of writing. That's 39. Here's where it changes just a little bit, number 41. 2x minus 1 divided into 3 equal groups is 5. This is just like a problem simple like that. In order to find out what cut in half will give you 10, if you don't already know the answer is 20, you multiply by the divisor. We can do the same thing here. The 2's cancel out here. If I multiply by the 3 here, the 3's cancel out on the left, giving me 2x minus 1 is 15, and then the rest of it is simple. Looks like you're going to have, what, an 8? So add 1, divide by 2. Condensing it a little bit. That's what 41 is. 43 is the exact same thing. And I'm only going to show you 43 because I don't want you to write no solution because you see a 0 there, and sometimes people get scared and think that means no solution. 8 minus 2x cut into 5 equal groups is 0. Just like we did here, multiplied by the divisor, we're going to do the same thing here. 0 equals 8 minus 2x. Let's subtract 8. Negative 8 equals negative 2x. And divide by negative 2, you'll get a 4. So just because there's a 0 within the equation doesn't mean your answer is no solution, or 0 for that matter. You got to be careful and solve it. I am going to skip all the way down to 51 because that's the only other thing, 51 and 53, that you haven't seen yet. Everything else is just a little bit more of what we already did. So here's 51. I'm going to do 51 and 53 with you. Whatever x minus 13 is, minus x minus 5 added to 2x is equal to 0. Here's the tricky part. This applies to that x and that negative 5. X minus 13 minus x plus 5 plus 2x. Okay, this thing here, this subtraction means you're subtracting x and you're subtracting negative 5 because these items are both within the parentheses. At this point, though, these parentheses serve no real purpose here, so you can just start combining stuff. X and a negative x cancel themselves out. The only x's I have left are those. And negative 13 and a positive 5 is what, a negative 7? 8? And 0. Add 8. Divide by 2. This thing here, when a subtraction symbol precedes the numbers within, you've got to make sure that you apply that subtraction symbol to both pieces within the parentheses. One more sample just like that, and I'll leave you guys go. Go to work. That would be good. Here we go. This last one, you might think, okay, well, what's unusual about this one? Well, we've got that negative business happening here and here. So b minus 1 plus 2b, remember a negative becomes positive, to which we're adding a b and a negative 3. So the sign doesn't change. Adding a negative means we still have a negative. Switching around the signs is the hardest thing. It's the easiest place to make a mistake. Looks like we have 4b minus 4. That look right? 4b minus 4 is negative 4. Looks like b is going to equal 0 by the time we're all done with it. Add 4 and you have 4b equals 0. It's not no solution. 0 can be divided into as many groups as you want, but you still have 0.